All right, so what we're going to talk about in this lesson are coterminal angles. Coterminal angles, okay? Now, before I can explain coterminal angles to you, what I have to explain to you first is the idea that the terminal side of the, from the initial side, that the terminal side of an angle can actually be negative. It can go down this way instead of going up this way. And when it does that, it becomes a negative angle. And the other thing I have to explain is that the terminal side, the angle, can actually be, when it gets around to 360, it can actually be larger than 360. It can turn again. So let me give you kind of let's talk about just language that people use, okay? I don't know if you've ever heard the phrase doing a 180, okay? You could say, well, he totally agreed with me and then out of nowhere he did a 180, right? That means that he turned around and disagreed in the opposite direction, right? Because a 180 goes like this. If a person is traveling in this direction and then they do a 180, they do a 180 degree angle turn, and then they go in the opposite direction. They were going this way, and then they do a 180 degree angle, which is a turn in the opposite direction, and they go that way. That's where the term doing a 180 comes from, okay? All right, well then there's the saying, oh man, that car, it was raining, and he slammed on his brakes, and then he did a 360. Okay, what does it mean to do a 360? Well, a 360 means to make one full circular revolution, right? The car was driving in this direction, and then it lost traction on the road, and it spun all the way around, and then went back in the same direction that it was going. That's called doing a 360, right? The car started going that way, and then it spun around, then it was facing the opposite direction, then it was facing sideways, then it was back facing the direction that it was going. It did a full revolution. It did a 360 degree angle. It created a 360 degree angle. It went in a circle and then kept going in the same direction it was going. That's called doing a 360. So now my question is this. What happens if a car on the road, if it loses traction and it does two 360s? So the car is traveling in that direction and then it loses traction because maybe the ground is wet or its tires are old, and it spins around once and then it spins around again going in the exact same direction. Well, you might say that the car did two 360s. But in math, we would actually say that the car did a 720, meaning it created a 720 degree angle, okay? Now, in order to understand what a 720 degree angle is, you have to first understand that a 720 degree angle is really a theoretical thing. It's not a physical thing. Here's what I mean by that. In a circle can only have between 0, so if here's our initial side and we're drawing a circle, we can only draw between 0 and 360 degrees, okay? Once we get to 360 degrees, it's a full circle. If we were to continue drawing on the circle, we wouldn't be creating anything new. So a circle can't have, or an angle can't be a 370 degree angle, because a 370 degree angle, if we went around again, really it would just be a 10 degree angle, okay? The idea of having an angle that is larger than 360 degrees is a theoretical idea, meaning that you have already done one full revolution and now you're on the second revolution of the angle, okay? So, with that in mind, let's now try and understand theoretical angle measures that are larger than 360 and even smaller than 0 degrees, okay? Let's start with the ones that are larger than 360 degrees, okay? All right, so here's the idea. Let's say that I have, I have the initial side and I open up an angle to about here, halfway between 0 degrees and 90 degrees, which would give us a 45-degree angle, right? Okay. So that's about 45 degrees right there. So this is our terminal side, right? And that this is a 45-degree angle, okay? If I were to now draw another angle that started at the initial side and it came around, came up to 90, came to 180 degrees, it went to 270 degrees, and then it came to 360 degrees, I could now extend beyond that and I could go another 45 degrees, and this side with its angle would now be basically right on top of this 45-degree angle, okay? It would be the exact same thing. Looking at it just without knowing what happened would make it a 45-degree angle. But the thing is, like a clock hand, it opened all the way. So this angle started here, it opened and did 360 degrees. And then it went beyond 360 degrees by another 45 degrees. And so 360 plus 45, that's 405. And therefore, this angle would be what is called a 405-degree angle. Now, here's the interesting thing, is that 405-degree angle, the terminal side is sitting right on top of the terminal side for the 45-degree angle. So they look identical. When two angles that have different degree measures have the exact same terminal side in the same, or have their terminal sides sitting on top of them, each other, in the exact same place, those angles are called coterminal angles. Coterminal angles. And the idea here is this, is that the terminal side of the angle is sitting in the same quadrant and pointing in the same direction, coming from the same place. They're sitting on top of each other, so you can't even tell that they are different angles, but they are different angles. We call them coterminal angles. Well, what if we now drew a third angle that started, that starts at the initial side, and it goes up and around, and then it goes up and around again, so that's 720 degrees, and then it goes another 45 degrees to there. And so now, here's the terminal side of this third one, right? And it's sitting right on top. It's in the exact same place as the terminal side of the 45-degree angle. It's sitting right on top of the terminal side of the 405-degree angle. And what this angle did, or what this terminal side did, is it went around 360, then it went around another 360, so that's 720. Then it went another 45 degrees, and that makes this angle a 765-degree angle. And here's what I need you to understand, is that 45 degree, if theta is 45 degrees, and let's say beta, I'm just using another Greek letter, and angle beta is 405 degrees, and let's say angle X is 765 degrees. Because the terminal side of this angle and the terminal side of this angle and the terminal side of this angle are all sitting right on top of each other, these three angles are coterminal. They are coterminal angles. Now, you may have already noticed how to figure out whether two angles are coterminal or not. If you're measuring in degrees, there's a very simple way to do this, because this is ultimately what I want you to be able to do. I want to be able to give you an angle measure, and then you tell me a coterminal angle with that angle measure. And basically all you have to do is notice that coterminal angles, the difference between all coterminal angles is 360 degrees. The difference between, the difference between 45 and 405 is 360 degrees. 405 minus 45 is 360. Also, 405 minus 360 equals 45. 765 minus 360 is 405. 405 minus 360 is 45 degrees. And so all coterminal angles have a difference of 360 degrees from each other. Or, well, I mean, you might say, well, that's not true for 765 and 45. Right. They have a difference of 720 degrees. 720 is basically a multiple of 360. Okay, and so all of the differences between all of the all coterminal angles is a multiple of 360 degrees, and I'll show you why that matters in just a few minutes when we answer some specific questions. Now, we could instead write this out in radians, because you need to understand every single angle that you understand in this class in degrees, you also have to understand it in radians. Okay, so what is a 45-degree angle in radians? Okay, well, 45, to turn it into radians, we're going to multiply by pi over 180, and so that's going to be 45 pi over 180. And here's the interesting thing is you may think, well, 45 is divisible by 5, right? And so is 180. Yeah, that's true. So this is going to become 45 divided by 5 is 9 pi over 180 divided by 5 is 36. Well, now you may notice that 36 is divisible by 9, right? And 9 is divisible by 9. So 9 divided by 9 is 1. So 1 pi, but we're not writing 1 pi, we're just writing pi. All right, so pi over 36 divided by 9 is 4, and therefore a 45-degree angle is a pi over 4 angle. So in this case, theta, that first angle right there, is pi over 4 radians. Okay, well, how about 405 degrees? All right, 405 times pi over 180 is going to be equal to, I'm actually going to cut to the chase for you. If you did this and you did 405 pi over 180, you could then divide 405 by 45, and you can divide 180 by 45, and you would get 9 pi over 4. And so angle beta, the second one there, is going to be 9 pi over 4. And then x, angle x there, which is 765 degrees, if you were to multiply that by pi over 180, you would get 765 pi over 180. Again, 765, that's divisible by 45. 180, also divisible by 45. And what you would wind up with is 17 pi over 4. 17 pi over 4. And now the question is this. Well, what is the difference between these? What is the standard difference between pi over 4 and 9 pi over 4 and 17 pi over 4 and 9 pi over 4? So what is the difference in the coterminal angles when we measure in radians? Well, remember that 360 degrees is the same thing as 2 pi. And so the difference between each of these coterminal angles is always going to be a multiple of 2 pi. If we were to add pi over 4 plus 2 pi, let's go ahead and do that. Pi over 4 plus 2 pi. Oh, this is a fraction and this is not a fraction. I need a common denominator. I need a denominator of 4. Well, what is the number 2 that has as a fraction with a denominator of 4? Well, it's 8 over 4. So this is the same thing as pi over 4 plus 8 pi over 4. So note, 8 divided by 4 is 2, right? Now we have a common denominator, so we can make this over 4. And 1 pi plus 8 pi is 9 pi. And so sure enough, 9 pi over 4 is the same thing as pi over 4 plus 2 pi. So if I was now to add 2 pi to 9 pi over 4, again, I need a fraction. So I'm going to make it 8 pi over 4. 8 plus 9 is 17 over 4, so 17 pi over 4. So these two are also 2 pi apart. So here's the whole idea with coterminal angles. The idea is that the terminal sides of coterminal angles are sitting in the same place, and the differences between the measures of all these coterminal angles are always 360 degrees apart, or a multiple of 360 degrees if you're measuring in degrees, and they're 2 pi apart, or a multiple of 2 pi apart if you're measuring in radians. Okay? And so what we're going to do now is we're going to walk away from the graph. I'm sure that makes some of you happy, probably. And I'm just going to give you a whole bunch of angle measures, and I want you to identify a coterminal angle that is between 0 and 360, or between 0 radians and 2 pi. All right, so we're just going to do a couple examples here. This says identify coterminal angle between 0 degrees and 360 degrees. Okay, so 573 degrees is larger than 360, so we want to go down to a number that is between 0 and 360. So all we have to do is subtract 360 from 573. Now, when we subtract 360 from 573, if we're still not between 0 and 360, we're just going to subtract 360 again. We're going to keep subtracting 360 until we are between 0 and 360. So 573 minus 360 is 213. Well, 213 is between 0 and 360, so we're going to write 213 degrees. Okay? And now let's say that we wanted to now convert that into radians. We could multiply it by pi over 180, and we would get 213 pi over 180, which is not reducible. Okay? And so if we turn this coterminal angle, we can represent this coterminal angle as either 213 degrees or as 213 pi over 180. Okay? All right, now let's do 1,000 degrees. Well, we know we're going to take our 1,000 and subtract 360, and we get 640. Okay, well, that's not between 0 and 360, so we have to subtract 360 again. Minus 360, and we get 280, which is between 0 and 360. And so a 1,000 degree angle has a terminal side that is in the exact same place as 280 degrees. Now, if I were to say, where is the terminal side of a 1,000 degree angle? Which quadrant is the terminal side of a 1,000 degree angle in? I know that it would be in the same quadrant as the terminal side of a 280 degree angle, which is between 270 and 360, so it would be in quadrant 4. Okay? So you can see that you can answer all the same questions that you've been answering in these previous lessons by first turning the angle into something between 0 and 360. Then you can convert it into radians if you want to, and you can also identify what quadrant the terminal side is in. All right, well, let's say we're given these questions over here, and now we're told to identify a coterminal angle that's between 0 and 2 pi. Now we want it in radians. Well, 23 pi over 7 is larger than 2 pi. I know that because 23 divided by 7 is larger than 2. So if you ignore the pi and divide the number in the numerator by the number in the denominator, if that number is larger than 2, then the overall number is larger than 2 pi. So what we're going to do here is this. I'm going to get rid of this arrow for a second, and I want to subtract 2 pi. Over here we were subtracting 360. Over here we're going to subtract 2 pi. So here's how I personally subtract 2 pi. I double the denominator, so this 7 is going to become 14. So I'll put 14, then a pi, and then over 7. 14 pi over 7 is 2 pi, right? Because 14 divided by 7 is 2. And so now all I have to do is 23 minus 14. 23 minus 14 is 9, and so I get 9 pi over 7. 9 divided by 7 is not larger than 2, and therefore 9 pi over 7 is between 0 and 2 pi, and so therefore the coterminal angle to 23 pi over 7, that's between 0 and 2 pi, is 9 pi over 7. These two angles, which are different measures, they are not the same angle, they just have a terminal side in the same place. I can also say I know that the terminal side to this angle is in the third quadrant because 9/7 is between let me write it this way. Because 9/7 is larger than 1 and less than 3 over 2. This is 1.5, and this is 1 2/7, and 2/7 is less than a half. Okay? So I know that the terminal side of this angle is in quadrant 3. Now I have 103 pi over 3, or 108 pi over 3. So I need to subtract double the denominator, 6 pi over 3. So here's what I'm going to do. This is not going to be one iteration. This is going to take me a few times, right? But basically what I'll do is I will just keep subtracting 6 from 108 until I get something that is between 0 and 2 pi. So I'm going to go 108 minus 6 is 102. So then it would become 102 pi over 3. Minus 6, 96 pi over 3. Minus 6, 90 pi over 3. Now, here's something you can do. You can actually, after you do a few of these, you learn that there's a way that you can divide by this number and figure out what the final number is. But if you have a hard time with that, just keep doing the subtraction, okay? So if I keep subtracting 6, 84, 78, 72, 66, 60, 54, 48, 42, 36, 30, 24, 18, 12. Okay, hang on. Eventually it becomes 12 pi over 3, which still, that's 4 pi, because 12 divided by 3 is 4 pi, right? So this is 4 pi. If I did 4 pi minus 2 pi, that would give me 2 pi. And so that means that my answer is 2 pi. Now, I could also give an answer of 0, because if I subtract 2 pi from this again, I get 0, and both of these answers fit between 0 and 2 pi. Okay, I say between, but obviously 2 pi and 0 are not between 0 and 2 pi, so you'd have to give one of those two answers. Okay, but the idea here is this. What I do is, the way I do it is I double the denominator, put it in the numerator with a pi over the denominator, and then I just begin subtracting 23 minus 14. If I needed to do another one, I would subtract 14 again. Okay? All right, let's now look at what happens when the terminal side, instead of going counterclockwise, what happens if the terminal side goes clockwise? All right, so what happens, or what do we call it, or how do we represent it, when the terminal side, instead of going counterclockwise, what if the terminal side goes clockwise instead? And from the initial side, it begins turning downward. Well, I call that backwards, okay? To me, what's happening is the angle is opening up backwards from where it normally opens up. So let's say that it comes down here and it stops right there, and our terminal side, stops right here. All right, well, there's a couple ways of looking at this. If you come across this terminal side, what you might think to yourself, well, actually, I'm not going to write terminal. Just know that this is the terminal side, obviously, because it's not sitting on top of the x-axis. If you didn't have any other information and you just saw the picture, your first thought would probably be that the angle started here and it opened up around here, and it would be, because it's in the fourth quadrant, it's somewhere between 270 degrees and 360 degrees. And you have a very good chance of being correct. But if this angle had opened backwards, what we would do is we would represent that on the graph as with an angle that's coming downward instead of going upward. When that happens, when the terminal side opens backwards, it's called a negative angle. It's opening at a negative degree or at negative radians. Okay? So, let's say that this angle, in a physical sense, is a 60-degree angle. What we would then say is that the measure of this angle is negative 60 degrees. Or if we were to convert that, 60 degrees times pi over 180 equals 60 pi over 180. Well, 60 goes into 180 and it goes into 60 also when we wind up with pi over 3. So what we would say is that this is a negative 60-degree angle or a negative pi over 3 angle. Okay? We would call the angle a negative angle. And that is a legitimate theoretical concept in this idea of the initial side on the x-axis and the terminal side coming backwards. Okay? Now, because of that, what's going to happen is our measures of degrees are going to be vertically inverted. Okay? And so we had 90 degrees up here, right? But now what's going to happen is if the terminal side opens to here where it's vertical going in this direction, if it's perpendicular, because the y-axis is perpendicular to the x-axis, we would have a 90-degree angle, but it would be negative 90 degrees, or negative pi over 2 radians. If this keeps going and comes over here so that we have an angle coming underneath here, this is still 180 degrees, but instead it's negative 180 degrees or negative pi. And so an angle that's created in radians, the angle that's created by the terminal side going clockwise and coming all the way around here is negative pi. So here's what that negative does. The negative indicates the direction of the angle. I don't know if you've taken physics, but one of the most important things you learn in physics, in kinematics, is the idea of velocity, right? And velocity is a vector. The idea of a vector is it has both a number, a magnitude, and a sign, positive or negative, okay? And the sign indicates the direction of the object, and the number represents the magnitude. So in this case, this negative pi, the pi means that it was a 180-degree angle. The negative means that the angle turned backwards instead of forward, or it went the opposite direction of the normal counterclockwise. Okay, I know that sounds really weird, but that's what it is. All right, if we keep going, if the terminal side goes from here to negative 90 to negative 180, well, if it goes a little bit further, another 90 degrees, that makes this negative 270 degrees, or negative 3 pi over 2 degrees. Let's get rid of this. And then if it completes the circle backwards meaning negative, then that would be negative 360 degrees, or negative 2 pi radians. So this idea of negative degrees and negative radians just means that the angle opened up backwards from the direction that it normally opens up. So now with this idea of negative, we can now understand coterminal angles relative to negative angles. So for example, see this negative 60-degree angle right here? Well, what if it had opened the other direction? What if it opened from here around to here? What would the measure be? Well, it would be from here, it'd go 90, 180, 270, and then from here to here, since from here to here is 60 degrees, here to here must be 30 degrees, right? So we can take the 270 and add the other 30, and that makes it a 300-degree angle. And so what we have now is angle theta, which we initially put was a negative 60-degree angle, We can also say that it was a negative pi over 3 angle. And so you may also want to know, okay, well, what is this in radians? Well, 300 times pi over 180 is going to be 300 pi over 180. Divide by 10, so cancel out a 0. 30 over 18, right? Both of those are divisible by 3. Actually, both of them are divisible by 6. 30 divided by 6 is 5, so 5 pi. 18 divided by 6 is 3, so this is actually a 5 pi over 3 angle, okay? And so, this angle theta, the negative direction, is negative 60 degrees or negative pi over 3. But if we represent it as angle beta, it's going to be positive 300 degrees or positive 5 pi over 3. And here's what I want you to see. It is exactly like what we did with the coterminal angles where they went larger than 360. The difference between these angles is 360 degrees. You can see here, if you add 360 to negative 60, you will get 300. If you add, and then the same thing here, the difference is 2 pi. If you were to add 2 pi, which is the same thing as 6 pi over 3, if you add 6 pi over 3 to negative pi over 3, you would get 5 pi over 3, and therefore these two are coterminal angles. So here's the basic idea, and we're going to do a couple examples in just a minute, and we'll be done with this particular lesson. Whereas the way that you find a coterminal angle with a really large angle is you subtract 360. If you have a negative angle, the way you find the coterminal angle is by adding 360. And the truth of the matter is that you don't have to always get it between 0 and 360 in real life. What you'll eventually understand, maybe you'll understand it right now, is that there are an infinite number of coterminal angles. So the angle 90, how many times can you add 360 to 90? An infinite number of times, all the way to infinity, right? And you can't get to infinity, so it just keeps going. How many times can you subtract 360 from 90? Infinite. And therefore, there are an infinite number of coterminal angles. And that's why in this class, what I'm going to be asking you for always is, what is the coterminal angle that is between this degree and this degree? And then at that point, you'll need to add or subtract accordingly. Let's do a few examples. Okay, so over here, we need a coterminal angle that's between 0 and 360, and the angle that we're given is negative 870 degrees. So angle theta is negative 870 degrees. So it's negative, so we need to get between 0 and positive 360, so we just need to keep adding 360 to negative 870. So I'm going to go negative 870 plus 360 gives me negative 510. Not there yet. Add another 360, I get negative 150. Still negative. So I'm going to add 360 and I get 210, and therefore this negative 870 degree angle is the same thing, or excuse me, it's not the same thing as, but it is coterminal to a 210 degree angle, which means that the terminal side of this angle is in the exact same place as the terminal side of this angle. Now, where is the terminal side of a 210 degree angle? Well, 210 is a little bit larger than 180. Well, this says negative 180, but when we had them in positives, this was a positive 180, and a little bit more is about 30 degrees down from here. So that would mean that this coterminal, or the terminal side of this, is right about there. So this is the terminal side of a negative 870 degree angle. It's also the terminal side of a 210 degree angle. And so we would say that the terminal side of this angle is in the third quadrant. Okay? All right, let's do negative 425. All right, well, negative 425, add 360, and I get negative 65. Keep going. Add 360, and I get 295. So 295 degrees, which is larger than 270, less than 360, and that means that the terminal side of this angle is in the fourth quadrant. Okay, and we can also convert these into radians if we need to, and this one would convert into, so if we multiply by pi over 180, we would get 210 pi over 180. 210 and 180 are both divisible by 30, and so we would get 7 pi over 6. And so this is the same thing if we wanted it in radians. A coterminal angle, 7 pi over 6 is coterminal to negative 870 degree angle. Okay? All right, over here, we're going to do our coterminal angles in radians. So we're starting with negative 18 pi over 5. We know that that is negative, and therefore it's not between 0 and 2 pi. And so what we're going to do is we're going to add 2 pi. And we're going to use the same technique that I mentioned before, where I double the denominator. So 5 becomes 10. So I'm going to add 10 pi over 5, right? Because 10 divided by 5 is 2, so I'm adding 2 pi. Well, negative 18 plus 10 is negative 8. So I have negative 8 pi over 5. I need to add 2 pi again. So I need to add 10 pi over 5. Negative 8 plus 10 is equal to positive 2. So we have 2 pi over 5. So the angle measure in radians, that's between 0 and 2 pi, that is coterminal to the angle negative 18 pi over 5 is 2 pi over 5. 2/5 is less than 1/2, and therefore the terminal side of this angle is in the first quadrant. Okay? And now this one, we're going to, it's negative 63, so we're going to add denominators to double that. That's 4. So 4 pi over 2. Now this is going to take a long time again. So what I can do is I can just take negative 63 and keep adding 4 until I get a positive number. So negative 63 plus 4 is negative 59, plus 4 negative 55, plus 4 negative 51, plus 4, 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 plus 4. Is there an easier way to do this? You know there's an easier way to do it. But you figure that out, okay? I'm just giving you the idea here. The idea is you eventually want to get to I'm now at negative 11, negative 7, negative 3, now I'm at 1. And therefore, negative 63 pi over 2 plus 4 pi over 2 a bunch of times will eventually become 1 pi over 2 or just pi over 2. Remember, we never type in 1 pi in our answer. It's just pi. Oh, if it's 1 pi, it's just pi. So pi over 2. So this is the same thing as pi over 2. That's a 90 degree angle, right? We already know that this is pi. Well, this is negative. But on a positive side, it's pi over 2 right here. So this is a 90 degree angle. Now, if you were asked about the terminal side, you'd have to say it's not in any of the quadrants because it is on the y-axis. Okay? All right, that is how we do coterminal angles. That is necessary information for what we're going to go to now in the next lesson, which is called reference angles.